So I'm going to start off with some slides here, but I'm going to try to get through them as quickly as possible because I think the real presentation's in the demo. I want to show you kind of the product. Basically, what I ultimately want to get to is really point number 4 on there. What can what we call the AVA switch sensor do? The points 1 through 3 are the slides, and they really set the stage, kind of set the background that will explain why I think that this is, well, as we see here, one of the most significant kind of technologies that I think I've been able to present in my career. And so to, give a kind of super quick background there, as Rudolph mentioned, I'm one of the co-founders here at Awake. Prior to Awake, I was first employee at Silence. Prior to Silence, I was an early employee at NetWitness. I came into NetWitness via acquisition, had started a company called Preventure. I think we nowadays call it kind of an EDR type technology where it took very low level telemetry from endpoints, collected it in a central location, and did analysis to compare, look for kind of outlier suspicious behaviors that way. And if we go far enough back, I really got my career started working on the Dragon IDS in the late 90s, early 2000s. So all that said, yes, I do think that this technology that I'm presenting to you right now is one of the most significant technologies that I've been able to present. Like, honestly, it's been available, or we announced it I think almost a month ago, and I still have to work to kind of wrap my head around it. So when we think about doing threat detection in the network, I can tell you that I was part of a team that evaluated companies doing threat detection in hardware in ASICs as early as 2001. The company I was at was interested in doing some strategic partnerships with other companies, trying to solve the problem of getting threat detection into routers and switches, all the way through to, we could fast forward to today. Right. And so this is just a kind of a graphic taken from, I think, one of the more advanced sort of Wi-Fi routers out there, consumer Wi-Fi routers. But this is something I use in a number of my test labs and use at home, too. The note here, we see this kind of advanced network security that's available, malware, ransomware filtering, stuff like that. Look, like everybody else, have been working at home for 2 years. I run malware for a living. I run ransomware for a living to analyze this stuff. I can tell you not once in the past 2 years has my work ever been interrupted because one of these devices detected what I was doing and stopped it. And, the kind of the punchline here, what we all know, when it comes to doing threat detection in actual network hardware, it's been bull malarkey. So you might look at that and go, oh, wait, Gary, I got an objection to that. Don't show us what is happening on the consumer side. We know on the enterprise, it's different. And really state of the art and what we see on the network side in the enterprise is using NetFlow for threat detection in the network, using, again, network hardware like routers and switches to identify threats. When you go out, of course, do some research. If you go to Google Scholar, I mean, if you could do it right now during the presentation, and do some searches for NetFlow, threat detection, keywords like that, you'll find anywhere from 10, 15,000 papers. If you look for just the past few years, depending on the keywords you search for. And there is no shortage of research out there around threat detection with NetFlow. Here's just a few. These are actually, these samples I selected here are some of the most referenced papers that I found in Google Scholar, just with some quick searching. We see we've got IEEE access at the top left there, just below it. IEEE Military Communications Conference, respectively, that was published in 2020. We got 2018 below that. Splunk conferences, of course, very frequently looking at presentations around NetFlow. And here's what's interesting, right? When we really start to dissect these papers, we really start to get into what NetFlow is being used for. Here's what we find. Here's this IEEE paper. Again, let me remind you, published in 2020. And what are they ultimately detecting? Code red, which, if you remember, is a worm from, 2001, maybe, somewhere around there. It's not only is almost nothing out there vulnerable to any vulnerability just like this one. Even you might object to this and go, well, wait a minute, there's still worms exist today, so there's still some value in this, sort of. Right. When we do look at the worms that are successful today, They're targeting totally different services. Their behavior tends to be much, much more selective. It actually is not the machine gun fire behavior we see from like Code Red. Not to mention the fact that, hey, let's just talk about threats to begin with. How common are worms? Extremely uncommon at this point. We can move on. We go through like these Splunk kind of presentations. So you see use case one. There were several use cases that were presented here. They're all basically the same thing, looking for outliers, top talkers, outlier by ports. And then finally, this other reference, the Milcom one, which is great, using machine learning. Most all these are referencing using machine learning on top of NetFlow. Here's machine learning to do DDoS detection. Like her, I have the same reaction to this. What? If we all know what DDoS is here, right? It's when the network or services go offline because the target is being hammered with just being overloaded, right? So services totally go offline. Do you need help? Do you need machine learning to detect DDoS? No. You will know it before any machine learning model ever triggers anything. You know what we do need help with is preventing and stopping DDoS. That's a very difficult problem still, but detecting this is absurd. So this is what's happening with NetFlow. All right, now let's get away from the publisher perish kind of papers that we see out there. Let's reset. Being a threat research guy, I like to, for me, ground truth is not what is being published in press releases and papers like this. It's what's the threat landscape doing? So if we just think about some of the big threats that we've seen over the past year, maybe two, the ones that have made the headlines, and there have been some really good research and technical papers released around. We've seen things like in SolarWinds, right? DNS tunneling, used for data exfiltration, command and control right here, right? And ransomwares more recently, at least up until the events in Ukraine, we were starting to see ransomware actors, leveraging DNS tunneling too. Encrypted TLS, I mean, depending on what numbers you believe, the numbers are still somewhere between 80-90% of all malware released currently is defaults to TLS, encrypted tunnels, of course. Why would you not? Post-exploitation tools, right? Metasploit, Cobalt Strike. I mean, we're even seeing Russia using Cobalt Strike in operations currently. So these are extremely common tools used offensively, like we said, command control, lateral movement, exfiltration, both by nation-state actors, ransomware actors, and pretty much everybody else in between. DNS tunneling inside of HTTPS, so a little bit of different flavor from DNS tunneling, used for data exfiltration, command and control. If I remember right, Cassia, we might have seen that in. I didn't mark it up here, but again, these are things that we all have been hearing about. Kerberos, all right, getting into some lateral moon examples. Kerberos exploitation, getting into credential abuse, enumeration of information from domain controllers, attempting to extract tokens and etc. Used across a number of different lateral movement tools and cases, and then even just getting into exploiting systems like Log4j. All right, what's the point of this list? The point is to ask the question, again, getting back to using the network to identify threats and mitigate them. What is NetFlow, the gold standard for threat detection in network fabrics themselves? What does NetFlow do for us in these types of threats? Absolutely nothing. We cannot use NetFlow to detect this stuff, right? And so, this kind of jars people sometimes. And one of the immediate questions I get is, well, wait a minute, why is NetFlow the gold standard? And to understand it, it's really just a matter of practicality. So we got a little diagram up here, pretty standard, diagram. Actually, real world network is good example here. So on the right hand side there, we have the internet. Next to the internet, we have the WAN routers, or what we tend to call the edge of the network, right? And what's always next to the edge of the network? We have, of course, the firewall, and right before, right after, most commonly right after, and for the organizations that can do it both, they do both. But we have the IDS or IPS or NDR or NTA or whatever acronym we want to use for it nowadays. And then, fine, okay, so we do threat detection there. What about all these other segments of the network, right? We were talking about lateral movement a moment ago. What about SCADA networks or these IoT devices or ICS and pivoting to attack these really sensitive? How do we detect threats there? And for most organizations, deploying NDR or IDS or IPS or whatever it is that they're going to use across all these redundant links, it's too cost prohibitive. You can't do that. So it's not done frequently. And so a lot of, the worst type of threats are completely unmonitored from a network perspective in here. Well, of course, that makes us stop and say, well, what can we do to detect in here? And of course, we use what we have, which are routers and switches, and they have NetFlow. And by the way, when I say NetFlow, I mean that as a kind of encompassing term for all the flow-based technologies we can use, or IPFix and others. Let's extract that data, put it in a central location, typically in a SIM or something like that. And let's try to do analysis on top of that and see what we can detect. But as we talked about, the threats that we're talking about, this data is not useful for. So let's pivot now. The Ava switch sensor, what I'm getting ready to show you, what I'm actually really most looking forward to giving you a demo of, getting away from the slides, going through our list of the common, relevant, high severity threats that we've all been reading about over the past couple of years. Can these switch sensors, keyword switch here, can these switch sensors do anything for these? Yes, they can. And I'm going to show you this. I'm going to show you actual detection logic. I'm going to show you actual data here in a moment, because it is, like I said, I've been working on this for like a few months now, and I still have to get my head wrapped around this. We're not talking about, when I say switch sensor, we're not talking about switches doing mirroring. We're not talking about switches doing spanning. This is the switch itself doing deep packet inspection. Okay, so I'm going to switch over to demo. I suggest setting a little alarm on your watch to go off maybe every couple of minutes, so you can remind yourself that you are looking at that data that has come from a switch, not an IDS, not an NDR sensor that's doing the deep packet inspection. It's the switches itself. So we have dashboard here. I'm gonna skip over that. I want to get to the tech. So I guess I'll take a minute here to explain. Let me explain the system itself, the NDR platform itself. So started off as a full packet capture system. I just kind of pivoted over to using this tab right here. You see activities, and we have basically all the traffic has been recorded. And so we can go through and do forensic investigation or hunting or any type of threat-related workflows around it. But here's the reality. And I've done IR for extended periods of time over the course of my career. And I can tell you, like, at the end of the day, do we care about packets? No. Do I care about IP addresses? No. I care about what devices, I want to find devices. I want to find what those devices are doing. I want to find who they're interacting with. I want to understand the characteristics of those devices, what separates them from others. That's what we spend all our time trying to figure out, right? And the packets, many times, honestly, they get in the way, right? It's the only source of the information where we could derive the answers that we're trying to find. But it takes a lot of work and very specialized knowledge to be able to do that over time. So if we come up here to the kind of the highest level abstraction, one of the highest level abstractions we have in the system, we ultimately have devices. And so, yes, we do full packet capture, but really what the system is all about is multiple layers of analytics on top of that network data to present the view of the network in the context that threat analysts, threat investigators, threat hunters understand, right? And so here we have, as you can probably guess, right, a list of devices, a list of systems that are on the network. I'm going to pick one here. This one I like this one. I'll explain why here in a second. So I just clicked on one of the devices. Give us a second to bring up sort of a profile of the device. It's basically telling us, okay, we have a Windows device here. I'm going to explain some more of this information here in a moment. This is actually why I picked it. We see a display of what we call threat cards. So these are the threats that have been detected that are associated with this particular device. Over here in fingerprints, I would love to spend like another half hour explaining. So this is a really powerful aspect of the system, but this is the platform telling us, the user of the system, here's the behavior artifacts or indicators associated with this device that separate it from other devices that are like this device, right? So this is not comparing this Windows device to some printer. Of course, they're going to be radically different from each other. This is, what is it that separates this Windows device from other Windows devices that are pretty similar to it? And if you're looking closely, there might be certain things here that catch your eye. And, we see default values of threat tools that obviously become a little bit easier to understand what the problem is with this device. Okay. But the reason I picked this one is because I still want to explain sort of what the platform is capable of before we get into the actual more interesting threat detection use cases. And so I just clicked on this button right here next to IP addresses. It's telling us that the IP address is this. That's the most recently seen one, but there's also two others. And what this is showing us is during a large period of time, this particular device has been sending traffic out. In fact, it appeared a while ago, but then started sending traffic using an IPv6 address. And the platform itself used the analytics engines to figure out, hey, these aren't two separate IP addresses. This isn't two separate, almost two separate protocols, right? This is actually one device with multiple IP addresses at the same time. So I'm going to take this traffic and I'm going to put it together. And we do this from the edge of the network, right? Where you normally, like that diagram, where you normally are going to have an NDR or network analytics system deployed. From the edge of the network, we fingerprint devices. We watch these devices move around over very long periods of time. We tell you, hey, this device has been on these different IP addresses. We don't need to integrate with your Active Directory or DHCP server or whatever else to make this work. It does it by watching the web protocols, by watching HTTP, TLS. In fact, TLS can be very useful for fingerprinting devices and identifying specific devices, watching move around. So we tell you, hey, this device has been on all these different IP addresses here. We see it kind of bounce back and forth for a little while. And this is not just some neat little kind of geeky cocktail party trick. This is a really, really important capability, because if we're going to talk about ML and AI, and we're going to talk about that stuff on network traffic, if you haven't solved this problem, and this is a lab environment, right? So that's why we see these kind of limited IP addresses. When you look at real world traffic, you're going to see a single device in a real world network probably has a half dozen different IP addresses in a single day as they move around from different conference rooms. IP addresses for those conference rooms may have, an Android device on it 1 minute, Apple next, Windows next, right? So a single IP address is going to have multiple different types of devices on. If you haven't solved that problem as a prerequisite, what do you think the results of the analytics are going to be on an IP address that's really 5 different devices in a day? Of course, it's going to be garbage. And that's exactly what we see, right? So this is a really, really important fundamental problem to solve to start getting into some of the more interesting activities here. So let's go back here.
I guess
yes.
you track the MAC address and then the
no, yeah. So good question.
IPv4 and IPv6, and in your database you stitch the two together to understand that is the same device?
We cannot use MAC addresses because we're sitting. Think about where your network's analytics systems are deployed. They're at the edge of the network, right? They're in between core routers, and so we don't see MAC addresses from any of these devices. So we can't use MAC addresses. We don't use them. Now there's an exception to that. If we get to see DHCP traffic, which is maybe half and half the time we will see maybe some from some segments. DHCP embedded inside will show an originating MAC address for where a request comes from. And great, in those cases, yes, we'll absolutely leverage it. But the reality is the vast majority of the time, the vast majority of traffic, vast majority of devices, no MAC addresses. So there's actually about a couple dozen different features that we use to ultimately fingerprint. I mean, it's a very simple one, but in HTTP traffic, you see cookies, right? And so cookies are identifiers for both people and devices, and so that's a type of example of even in TLS. Actually, TLS can be used to fingerprint types of devices, and so we use, like I said, a number of features that we ultimately put together, and we can create a fingerprint for a device and watch it move around. And sorry, go ahead. Look like you're.
So more or less the identifiers are in the upper application protocols.
Yes.
That you use to stitch the two together. Then you go down and say, okay, that was IPv4 address, that was an IPv6 address, and I can combine these. Yeah?
That's it.
Okay, got it.
All right. So yes. Okay. So we ultimately do profiling devices, like that. Now, when I use the term device, when you see the term device here, this also tends to be synonymous with internal system. But what about all those external systems, right? Which really mostly tend to be destinations. So we have this other tab over here. It's labeled domains. I tend to think of, domains and destination pretty synonymously over here, but we do the same type of profiling, just pointing it out quickly. We do the same type of profiling for destinations. There's a difference in the type of information you ultimately see when we descend into these detail tabs. And that's really because, when we're looking at a device, an internal device, we're probably going to see a handful of different protocols. The vast majority of the time, we're going to see, we're going to see a larger breadth of activity that we can understand that system a lot more than an external system. We're just going to see pretty much a smaller set of activity. And so there's a different kind of set of profiles, but we still fingerprint those external destinations in a similar way, right? And we're trying to figure out not only what types of protocols, but what are the patterns? How common is it for a device inside to communicate? What do those patterns of communication look like across different devices, things like that, and come up with profiles of those external devices too. All right, so very high level, right? The system, first thing it does is takes raw network traffic and gives us, turns it into objects that as a security professional, we understand, right? Systems, behaviors of those systems, things like that. Now, let's get into some of the threat detection that you can do once you've done stuff like that. So I'm going to come in here at the top bar.
You said you're not using NetFlow. Expand on that last sentence. So you're not using NetFlow. How are you converting the packets into information that you're then going to analyze? What are you doing?
Let's forget about switches for 1 minute. The traditional way this is done, right? You have a 2U server that's collecting traffic, logging packets, recording it, etc. And ultimate deep packet inspection. When we say deep packet inspection, that's synonymous with some XU server that's recording traffic and doing all the parsing. Right?
Okay.
This is why I say that this is one of the most significant technologies I've been able to present in my career. We're now doing that on the switch. The switch is not sending NetFlow. It's not mirroring traffic. It's not spanning traffic. It's parsing the traffic. And that parsed record is now what's coming back and being analyzed.
So
it's a complete breakdown of what's going through. And I'm going to show you just how detailed that is in just a second here. Yes.
Show me where you're doing it. There's a limited number of places you can access that inside a switch. How the hell are you doing it? And then where are you?
So I'm on the threat research team, and that means my involvement in the project has been coming in towards the end, once it was actually functional, and evaluating how effective it is for threat detection. And I'm going to be honest with you. Coming into it, my baseline for what I would have considered success was, maybe 20, 30% of the detection that the full-blown standalone solution could detect. It is a multiple of that. It is far, far more than that. And I am not kidding when I say I still have to get my head, like the internal status meetings we had where I was going and delivering the results of this testing and validation. I was stuttering my way through these presentations because I didn't even get it. I didn't get how this was possible. I think we'll probably be publishing some more papers on that soon because it's mind boggling. But let me show you some of the detection we can do. I'm going to show you just two real quick examples. So I think a good one, let's look at uncommon. So adversarial models is showing us the threats that have been detected in this traffic. I like this one. Let's look at that. So we are going to look at what we call a model. That's a threat detection. As you saw, called lateral movement, uncommon share, sending or receiving executable code. I'll just show you what it's detected. We're going in. This is the actual detection logic. This is another part of the system that I love. All our detection logic is it's an open language. You can come in, you can see even the ML-based stuff, which is what I'm showing you right now. You as an analyst can come in, learn from how these detections are written, write your own, create your own, copy these, do whatever you want. And so what this model is doing is ultimately with this line saying, hey, show us all the traffic, ultimately SMB traffic, shows all the traffic that is, from a device going to a share that's it's not like kind of commonly accessed in the network as when we look out there, not the kind of, common file or common share that, most or even some other systems or a lot of other systems are doing. And then we have some other kind of fine tuning logic here, just saying, and, in everything that's returned back, let's just filter down to executable kind of file types. And we're also making sure here that it was actually written. So we're saying we're looking for uncommon files being transferred via SMB somewhere else. That's basically what this logic is doing. But here, let me show you. This is the cool part. I'm going to come in here and we're going to look at a summary of all the results. So feature summaries. I'm going to filter down to file name. Bring up the file names here. That will take a second to kind of populate. If you're looking, I know it's probably a little bit of an eye chart here. I apologize. I hope you can see it okay. But you may recognize PS exec, Mimikatz. What else do we got here? Netcat, Metasploit, PW dump, right? This is one threat detection model that when you look at like how these threats are detected across other systems, almost every single one of these will have its own detection. And then when some new tool comes out, new detection for it. This is, we're doing this one model, right? Looking for these kind of anomalies. So this is what's fascinating to me, right? Is, from the switch, again, remind yourself, we're looking at a switch. Switch parsed this traffic. Switch told us this is what's going across the network. And then analysis was done on top of that. One model detects wide variety of threats. Very cool. But last thing I want to show you here is the automated investigations. Okay, so we can detect threats, but there's still more work to be done, right? Right here we see a CACBot infection. In fact, we come down here, CACBot C2. So this is the model that triggered. Right here. But what happened before that? Before that, this system actually visited some other IP addresses that it hadn't visited before. Of course, if you ask the question, how common is it for a device to do something it hasn't done before? It does it a bazillion times a day. It does it all the time. Just because it did it for the first time doesn't mean anything from a security context. It needs to be suspicious. There needs to be evidence that these things are suspicious. So it bounced around between these IP addresses. Ultimately, this is where the exploit was delivered from. And then we see after the initial sign of CACBot C2, this device starts visiting domains that it hasn't visited before, and we see that these domains ultimately are suspicious. How do we know that? I'm going to come up here to supporting artifacts, and the thing I want to point out to you is a model triggered a human being, which is what this icon represents. A human being said, I'm interested in that model. Let's investigate it. These little robot-looking icons represent Ava, as Rudolph talked about. Ava did this entire investigation for us. Not only found what was new, what was done for the first time, but even went out, it does internet searches. And then it does an internet search for this domain. Based on those results that come back, it goes and it uses natural language processing to read the page. What is the internet saying about this stuff? Is it talking about, anything threat related, right? So it's not just checking known bad, known good, anything like that. Right? Because we know the effectiveness of those. It's not great. It's actually going out and doing an investigation similar to the way a human being would do it. I'm just scroll down. This is all Ava. The complete investigation was done by Ava. And so, like I said, a lot to pack in.
Typically when you're getting data off a switch, NetFlow, span, mirror, if the switch management gets overloaded, it gets dropped. Is that the case in this as well?
Like dropping the parsed data.
Yeah.
Yeah, if it gets overloaded, it's the equivalent of drop packets. Now, what those numbers are for those thresholds, I don't know offhand, or I don't remember offhand accurately, but yeah, it does behave the same way. But we're not talking like 100 meg flows, like to reach that point. Like it's much higher. So what I wanted to show again was, we started with a switch is ultimately sending information that everything I showed you was from a switch. Everything we looked at from a switch, right? From the traffic to the abstraction of getting in. Let me go back here, right? Actually, we'll go, all the information about all these devices on the network. I can drop this down. We can do, feature summaries. Let's look at device types real quick. Bring this up. So again, we fingerprint the devices. We watch them move around the network. We tell you where these devices have been. We tell you what these devices are. We tell you the characteristics of those devices, what separates them from other devices that are somewhat similar to them. What are the interesting artifacts or characteristics or things that are going to be relative to an analyst, either because they have a security relevant context, or as an analyst, you're just trying to understand, what is this device I'm looking at? What is it that makes this device? All of that done from switch data. So, this is impressive just for NDR alone. But then again, the part that I promise you, I'm still trying to wrap my head around, the fact that a switch is ultimately the source of information for all this is what's phenomenal. the reason I say, and I started off with that slide that, may have been a little melodramatic. This is the most significant, technology I've been able to present in my career. But it is true. And the part that we all know someday it was bound to happen. Did I expect to see it now? No. Did I expect to see the network itself doing threat detection on par with, threat detection point solutions? Right after 20 years, we're just used to the network does networking, and the industry leaders in networking do networking. And then there's some industry leaders in security, and they do security. And those two things are separate because the network has never been able to do security, or I should say, let me rephrase it, has never been able to do threat detection, threat identification, as well as the point solutions. But now it can. Now it's the network itself providing threat detection on par with some of the most sophisticated threat detection solutions there are. And so that's why I was very excited to be able to deliver this.
How many apps you detect and, let's say, analyze? Do you have a number of applications, protocols? You were mentioned a couple of those, but yeah.
Yes. When it comes to application identification, hundreds approach. I don't know if it's over 1,000, but it's in that neighborhood. When it comes to number of threats, we do have information around that. We've kind of mapped it to the MITRE ATT&CK framework to make it easy, more of an apples to apples comparison, or easier to understand, rather than just giving a whole bunch of list of threat detection models. But the thing like the example I showed of the SMB example, right? That's one model that detects Mimikatz, PsExec, PWDump. Like, these are radically different tools, but they all have some similarities, at least from that model's perspective, of what separates them from normal, legitimate traffic, right? So the number is large. We put a lot of time into that intentionally, because the reality is I don't want to be in the business of writing, signatures.
You can expect all the usual suspects, DNS, DHCP, whatever it is, SMB you have covered, yeah?
Yes.
Okay, great.
Yes, definitely.